All right, we're ready to start with variation of parameters. And just as a reminder, the idea is we've got this problem here, a second order non-homogeneous differential equation. And the idea is that we have undetermined coefficients to deal with functions here that are either exponentials or polynomials or sine or cosine. And this works for more general functions f of t, unlike the undetermined coefficients. Now the setup of this is a little bit complicated, so you can kind of watch through and see how this works. We're going to develop it once, and at the end of all this, we're basically going to have a set of formulas that'll be given on the formula sheet, given on the test, and so on. So when it comes to actually doing the problems, you're not going to have to go through this setup. But I do want to show you the setup just once so that you can get a sense of where this is coming from. So if some of the details seem a little complicated, don't worry too much, but follow this kind of as best as you can. So the setup is basically we start by looking at the homogeneous equation. So again, just like we did with undetermined coefficients, we're going to find this homogeneous solution. And the major assumption of variation of parameters, the key that makes this method work, is we make an assumption, another assumption. And it turns out that we assume that instead of having constants C1 and C2, those C1 and C2 can actually be functions. That's kind of the controlling assumption that is the key to this whole setup. So we're going to call these V1 and V2 for these are the parameters that we're going to vary, is kind of the idea. So we'll call these the parameters similar to the constants. So instead of C1 and C2, we're going to have something like V1. I'm going to write V1 of t just to emphasize that these are functions of t and not just constants. They could be constants, certainly, but in general, we're going to assume that they are functions in general functions. So then the solution, this y equals the solution. So the entire problem basically boils down to finding what v1 and v2 are. If we knew what v1 and v2 are, then we would know what this particular solution y sub p is. All right, so that's the goal, is to now solve for v1 and v2. And this solving for it, this is the part that's tricky and somewhat complicated. So we're only going to do it once. And we'll keep everything general here. And then after that, just use a formula. So when we do it once with a general v1 and v2, we're going to find the formula or the set of formulas that will help us calculate them later on. So that's kind of the approach. The core concept is that you replace these constants with functions, and then we will solve for them now. So let's get into it. When it comes to finding these parameters, one of the reasons this is kind of complicated is that there are a couple of assumptions that we make along the way. And it's always hard to see these assumptions being made because they generally are not based on something that we can tie back to things we've learned before. So we kind of just have to follow this process. You know, somebody has developed this and we just kind of watch it work. But obviously it wouldn't be anything that I would expect you to have guessed at or anything like that. So if we're going to find these two parameters, the basic principle, of course, is that we need two equations if we're going to solve for two unknowns. Right? So the two equations we're going to use are going to come from a couple of places. So starting with this solution here, right, the general version with v1 and v2 as our parameters. We are going to do something similar to what we've done before, where we're going to take that and substitute it back into here. Now, there's going to be a restriction we put on this just to make our lives a little bit easier. So first of all, if we take y prime, now using the product rule on each piece, right, so the product rule here, this would turn into v1 prime y1 plus v1 y1 prime, right, the product rule for the derivative there. And then similarly for the second half, this would turn into v2 prime y2 plus v2 y2 prime. All right, so far so good. Now, if we go on to get y double prime, we're going to run into an issue here where we're going to end up with, if we do this again, we'll end up with v1 double prime and v2 double prime. Now, that doesn't maybe seem like an issue right now, but looking ahead a little bit, what's going to happen is we're actually going to solve for v1 prime. Sorry, we're going to solve for v1 and v2 here. So we don't want to deal with v1 double prime because that will ultimately cause more trouble when we get to the end and try to integrate. So if we have v1 prime, that's okay, but if we have v1 double prime, it'll be an issue. So anyway, long story short, we're going to avoid having v1 double prime and v2 double prime. So we're going to assume that these pieces that have v1 prime and v2 prime combine to be 0. So we'll assume that v1 prime y1 plus v2 prime y2 equals 0. And by doing that, now when we kind of take things one step further, let me rewrite y prime with that assumption. So that assumption leads to, do this in red, that assumption leads to this, which means that this piece and this piece add up to 0, so they together go away, which means all we're left with is this here. Right, so we made this assumption, and that assumption is going to be the first equation that we're going to use in this system. Right, so again, this assumption, it doesn't maybe seem like something that we've seen before, or doesn't seem to tie back to what we're familiar with. So we kind of just have to see that it works and go with it. There's not a lot of background that we can use to justify that. So with that in mind then, y double prime, again applying the product rule here, we've got v1 prime y1 double prime, sorry, y1 prime plus v1 y1 double prime, and then the same thing with v2 and y2, like so. So then we plug these back into our equation, the differential equation we're working with. Now, bear with me for a minute. I'm going to write all this down. It's going to be really, really long and complicated, but eventually things are going to sort of simplify out. So just for a minute, stick with me here. We're going to have A times all this plus B times y prime. Remember that's v1 y1 prime, v2 y2 prime after making the simplifying assumption, and then plus C etc. equals f of t, or just f. Now, to rearrange this, remember our goal is to solve for v1 and y1. So let's break out all the terms that have v1 in them. I don't know how much detail I want to show here, but basically, we'll skip some steps. If you factor out all the v1 terms, so for instance, if you distribute the a, distribute the b, and distribute the c, and then collect together all the terms that have v1, you'll get these here. So you'll have an a v1 y double prime, b v1 y prime, c v1 y1. And then if you do the same thing with v2, again, you're going to have an a v2 y double prime, a b v2 y prime, and a c v2 y, but with y2. And then all the other terms that are left are going to be, notice we used all this stuff already. So the only terms that are left are the a multiplied by this and this term. So all that's left is a times v1 prime y1 prime plus v2 prime y2 prime. And all of that equals f still. Okay, now how does this help us? Again, it's easy to get lost in these details, but kind of follow as best you can. Since y1 and y2 are solutions to the homogeneous equation, that's going to equal 0, and that's going to equal 0. Right, so since they're solutions to the homogeneous equation, that means that specifically they satisfy this equation, ay double prime plus by prime plus cy equals 0. So that kind of, everything falls off from those two pieces, which is kind of how this works in our favor, which leaves just this part alone. So if we just write that down, we get basically dividing both sides by a, we get f over a. And there's our second equation of the two that we wanted. Right, so we wanted two equations, and those two equations, I'll write them down again, but you'll notice they're both equations in terms of v1 prime and v2 prime. So at the end of all this, and again, if some of this detail got lost, that's okay, but at least you can go back and look at this if you need to. At the conclusion of all this, we have these two equations. So there's our system of equations that we need to solve for v1 prime and v2 prime. Remember, y1, y2, all of these are known values. They're known because they're the solutions to the homogeneous equation, the homogeneous version of the equation. So the unknowns are v1 prime and v2 prime. If we can find v1 and v2 prime, then we can integrate each of them to find v1 and v2, and then we're done. That's kind of the whole setup to solve this. So in terms of actually doing one of these problems, you'll start here, you'll find this, and then you'll jump straight to the formulas for v1 prime and v2 prime that we'll write down in a second, and then you'll integrate those to find v1 and v2, and then you'll have your final solution. So that's kind of the breakdown. So as far as actually doing the problems, you're not going to go through the steps that we've just gone through, except just to see them this once. So I'll skip the algebra here, just for the sake of sanity, if there's any of that left. So we're skipping the algebra of how you would solve these, but it's just a system of two equations. The complicated thing is just that you're using general values here instead of sort of numbers that you're more familiar with. But the point of all this is that you get v1 prime equals negative f y2 Now stick with me. This looks kind of ugly, but it'll get better in a second, don't worry. And then v2 prime has actually the same denominator, which may or may not be surprising to you. And the numerator is just f1, or fy1, sorry. Right. So there's our solution to this system of equations. Now, if you look closer at this system of equations, you might notice a little bit of structure that may or may not look familiar. Sort of hidden within this, there's actually a matrix. And depending on how familiar you are with matrices, you may recognize that there's this structure where you have y1, y2, y1 prime, y2 prime, which, in case you haven't forgotten already, that looks like the Wronskian, more or less. And it turns out that if you look closer at this right here, you'll notice that's exactly the formula for the Wronskian that we wrote down in a different video. So putting that together, basically it allows us to write this formula much more concisely. By noting that this, what's in the brackets here in these formulas, is equal to the Wronskian of y1 and y2. So now we can write down the final version of these formulas. v1 prime equals negative f y2 over aw. v2 prime equals f y1 over aw, where w is the determinant of this matrix. And this right here is what you'll see on the formula sheet that's posted and that's available for your exams. So this is what's given on the formula sheet on the exam. So if all you have is that formula sheet to work with, the part that you really have to know is how to calculate the determinant of a 2 by 2, where you take the product here, then the product here, and subtract in that order. So if you can do that, then finding v1 prime and v2 prime is a fairly trivial exercise in a little bit of algebra that you do. Then the only tricky part that can come from, at that point, is to work backwards by integrating these. So if this result is something that's hard to integrate, then it might be a hard problem. But if this comes out to be something easy to integrate, it's a very easy problem. So the problem of variation of parameters really depends on what that form looks like as far as how difficult it's going to be. If that's a complicated form, the problem might be hard because integrating might be hard. But otherwise, you're just computing very straightforward things. A is the coefficient of y double prime in your equation. y1 and y2 are your homogeneous solutions. W is the Wronskian of those. And then f is the forcing function in the original equation. So you just kind of drop everything into the formula here. And again, then the last step is to integrate to find v1 and v2. So we'll see a couple examples, but the general setup, the theory is complicated, but in practice, you kind of just drop it into the formula.